Purpose of an operating system, as we discussed last time, is whenever an underlying hardware, the programming ability of underlying hardware by its structural resources, if that is not sufficient or adequate to cater the need of an application, then operating system would come to rescue as an agent or catalyst in order to just make sure that the structural resources of underlying architecture would give proper service to expected applications. This is what in nutshell we discussed last time as an basic utility or basic usage, or we understood WHY, that is why operating system is needed in this particular way. Okay, and we are about to discuss now the various facets of operating system along with its different types or the different services those are getting provided to this. Okay, so again, continuing with the purpose and functions of operating system that we left out from the last time. Okay, so a few of the slides that I'll be just making it repetition for sake of the continuity. So we'll once again revisit the concept of operating system. We'll see what this operating system really does, and how the different developers or how the different users of operating system would see at operating system as a benefit to them. Then what are the different services that operating system normally does provide, and what are the structures and consecutive types of an operating system. This is what we intend to discuss in this particular today's class. Okay, fine. So let's continue with a brief discussion of operating system. As we already understood that operating system is nothing but it's an interface between the underlying hardware and the user's program, or application, or the interface between the underlying hardware and this application program. So this particular interface, as we have seen, is there on both the sides of it. Okay. Devadatta, am I audible clearly?
Yes, sir.
Is there any lag in audio or video, something like that?
No, sir, I don't feel it.
Okay. Please sit carefully. Like if at all audio lag is there, then audio and video lag is there, please let me know. Okay. Fine.
Yes, sir.
Okay. So as we were discussing about an operating system being an interface between underlying hardware and the application program, this interface happens to be there on either side, that is at the hardware side as well as on the application layer side. Hardware side interface, as we understood, referred as an port, and the application side interface, as we understood, as a system calls, or it's also going to call as an application programming interfaces, right? So in the services of an operating system, as it can be seen from this particular diagram, the program execution, that means scheduling of the different tasks that would constitute the program, that would be one of the very prima facie activity that we called as the scheduling activity of it. Then the IO operations, performing input-output operations along with the service of an operating system, maybe in the form of providing some kind of drivers to it. Then file management system, file reading, file opening, file copying. So all this file management system, which is necessarily be related with a memory management, or which is necessarily be related with the manipulation of the memory space, as we could see in the latter part of it. Then there happens to be a different communication among the tasks that we call as an inter-task or inter-process communication. And via this communication, we are going to achieve the synchronization process, as we have seen it last time, and we'll see it in the more elaborative service of an operating system. Then how does, whenever any application makes use of the different resources, so it is being required that a different task, if we have got an application to be as a multitask application, then it is to be make sure that if the common resources are being there for this multitask application, then at a given point of time, only one task should be allowed to access that particular resource. I mean, mutual exclusive access of a resource to the task is also becomes a very important activity. And this resource allocation, resource management, resource synchronization happens to be the services of this particular operating system. And as we also seen that the accountability of the task, like how much CPU usage time is being occupied by a specific task, that is some statistical parameters, statistical activities are also expected to be known by this operating system. And along with this particular providing the different protection and security to this particular underlying interfaces or the hardware or the application program is not supposed to make use of the operating system directly without having an API, without having a system call onto it, isn't it? Because operating system is expected to be protected against the access or malicious access from any user's application, right? So these are few of the exemplary services that we have seen. The more detailed services that would be enlisting into the latter part of this particular session. Okay, so this is in short as a bare concept of operating system, where it happens to be an interface between, or it is basically an interface between the application program and that of an hardware. Okay, so moving further, let's try and understand what exactly this operating system is, this with some simple definitions. So as it is being said that it is a program that intermediary between a user of a computer and the computer hardware. This is what we've been discussing from quite a long time. Then we have what exactly the operating system goals at. What are the goals of the operating system? So in the goal of operating system, we can see that it primary goal is to execute the user's program and makes solving users problem easier. That is means to assist the user in order to make use of the operating system services which might be written or which may or may not access the underlying hardware. Then make this particular computer system convenient to use as far as the general purpose operating system or desktop operating systems are concerned, and then use this particular hardware in an efficient manner. Likewise, whenever you are connecting some new device, for example, you are connecting some camera, you are connecting some kind of audio device, video device, printers, all these peripheral devices to the system, when you are connecting it, these devices necessarily comes with a drivers. So getting registered those drivers with an operating system is mandatory, because operating system provides some set of services via this particular device driver to those particular devices in order to make this particular exploration of the devices in more convenient manner. This is what we can understand as a general goal of this particular operating system. So in a nutshell, a multi-programming ability, then make this user convenient to program an application without knowing a greater detail of the hardware. And as well, whatever the peripheral devices, those are expected to be used in the system, those should be used very efficiently. So these are the three principal goals. Those are being given in the literature related to an operating system. Okay. Then what this operating system would do? Now, fundamentally, if you ask me what this operating system would do, then this is completely going to be, depends on the point of view of user. For what purpose the user is making use of an operating system, that particular point of view is going to define what that operating system would do for that particular user. Because operating system, as we know, it's a system software meant for almost assisting the user for almost everything. And that is what it depends on the point of view, like for what purpose this particular operating system is being used for. Okay, like for example, I can just cut short a discussion in a short, and I can let you know that from our embedded system perspective, that if I'm using a general purpose operating system, then general purpose operating system, when it gets seated onto the desktops or laptops, then the basic purpose or the basic functioning of this operating system is to provide the maximum throughput. That is, this operating system should be able to manage or able to control n number of tasks in whatever the scheduling algorithm that is being found into that operating system. That means number of tasks that would be executed or performed per unit time in order to maximize the throughput of the system without having a corruption, without having a lot interdependency on each other. I mean, this is what to be referred as an view, or this is what to be referred as an functions, that general purpose operating system that we are using at the moment, right? Like Windows operating system, Linux operating system. So these operating systems are basically provides the user interface along with maximizing the throughput of different tasks. Okay, so this is an example. Like in the embedded system perspective, I might not need the operating system that provides the greater throughput, because in embedded system, as being defined itself an application specific, I might not have n or many number of tasks. And when I don't have many number of tasks, I really don't expect any throughput from this particular operating system. So this design objectives or design goal of the operating system, when I'm using it for the embedded application, that would be more towards managing this task very effectively with the different scheduling algorithms as well, managing this particular task, not to get stuck into the dependency issues among themselves, as well how this particular operating system would provide the service time which would be known constant and known deterministic and constant, which should be known a priori. I mean, these are what the requirement that comes out from the operating system when I'm using it for the embedded applications. If you're catching up my words, then you would understand it very clearly that the user, the way in which the operating systems a user wants to get it used, it is going to provide that kind of services. It's going to provide that kind of functions. Okay. So that is what categorizing applications or the services or the functions of operating system in a single category, that might not be a good approach, or that might not be feasible even from the understanding point of view also. So as I'm saying that it is depends on the point of view. So let's see what kind of point of views can be there onto it. So as I say you, that user wants convenience. For example, ease of use and good performance is what matters to the user. So so these kind of users who are expecting ease of use as well as good performance might not be so concerned about the resource utilization, because here that particular user doesn't concern about that resource utilization altogether. So point of view is completely different, right? But shared computers such as mainframe or mini computers must keep all users happy. That is what I was talking about, the throughput. We understand that most of the time, the algorithm that runs in the desktop operating system is multi-programming with the help of time shared mode, right? So in this particular time shared mode, equal time slice is assigned to each and every task, and it keeps on repeating that particular number of tasks in a round robin fashion, maybe more specifically. And whenever it gets a turn, it gets executed, isn't it? But it has to be done in so fast that every application or every task should feel that operating system is exclusively providing access to it. So that kind of less time switching, faster time switching, that gives the maximizing throughput, and that gives the feel that virtually the operating system is attending that particular application or task in exclusive fashion. So that is also one of the necessity, or that is also one of the need that could be highlighted from the user's perspective. Then with respect to the workstations, they need a dedicated resources, but frequently use shared resources from the servers. That is also true. The way in which, like, that is what we have, the server OS are different, workstation OSs are different, because the way in which these OS are expected to be used or for an application, that is going to define its function, or that is what going to define its utility. That's what an exemplary case it is being given. The operating system that is being used for workstations, as they are being expected to make use of the dedicated resources, the shared resources, as in the case of the servers, that might not be a lucrative option for OS that is being used for the workstation, isn't it? So that is what, like, the different operating systems came up with the different file management systems or different networking systems, right? So you might not, or you might see in the future that operating systems are, as per as the network protocol or network stackings are being written onto it, they are now being more focused towards and building an IoT systems for everything now. So in the future, that might not be a wonder, like operating systems comes with a package of different security and protection reasons, or the protection algorithms that the current IoT system would demand for it. I mean, these kind of services would be even provided as a package of operating system. So depending on the requirement, I mean, this particular requirement is going to drive the design of an operating system in nutshell, that we can understand at this moment. Okay. So like handheld computers, computers are the resource poor. So for example, optimized for this usability and for the battery life. Like if I got the handheld computers or PDA kind of devices, which makes use of an operating system, then basically it is to be optimized for the usability, like for the multitasking, the task switching should be fast and all that, as well as it should provide me a better or stronger battery management utility inside it, so that the battery life would be extended one. I mean, all these are sample cases that we are discussing, like what operating system would eventually do in response to the answer where it depends on the point of view. Okay. There is one more example that you can see that for computers such as little or no user interface, such as embedded computers in devices or automobiles, it hardly means. I just made it in a red because our concern, as I told you, to understand the operating system is towards an embedded applications. That is what, from our point of view, the operating system that manages the execution time in order to meet the task deadline, that would be more concern to us rather than offering of throughputs, offering of maybe battery management. We will appreciate definitely. But the primary focus of operating system for we people, for embedded system designers or embedded system developers, would be more towards how does this execution time would be managed by scheduler, execution time would be managed by the different timing services of operating system in order to meet this particular time deadline. And that's what the operating system, which are being basically meant for such kind of purpose, is referred as real-time operating systems. And that is what we are about to discuss. And we are discussing this operating system as prerequisite or prima facie knowledge of operating system in order to directly launch into the real-time operating system. Okay, so I repeat my point. The discussion of operating system from our for our perspective or from the perspective of our course is definitely going to be how does the operating system is going to manage the execution time and how it would help us to meet the different task deadline in order to have the output of our system within a constant known a priori time. Means we need an operating system whose service times should be known to us well in advance, which should be deterministic and constant. Means by making use of this service time, I should be able to build up a simple algebraic equation, which will give me an estimation of the total time execution, including an operating system service time. So that gives me a deterministic, that gives me a high amount of knowing the things well in advance. That kind of ability to predict the system performance well in time, well ahead of time. This is what the prima facie requirement that comes out to be as an embedded system requirement or real-time system requirement. And our objective is to understand this particular operating system from that perspective. And we will be orienting our discussion to that level itself. Otherwise, we'll see that there are many standard books or volumes, I would say, which are being written onto operating system, because the scope of operating system is very large, very wide scope is there. We are looking at operating system from our perspective of making it used for the embedded applications. Okay, fine. So let's move ahead to understand few of the standard definitions which are being given. So OS can be referred to be as a resource allocator. That means it manages all the resources and it decides between the conflicting request of efficient and fair resource use. When I'm saying it's a resource allocator, the job of resource allocator is not merely to give an access of the resources to the task. No, but it has to analyze the requirement of access of the resource to the task. And after analysis, it should come to know, it should able to resolve the conflicts in case the multiple task demands for the same resource. And based on some kind of arbitration logic, based on some kind of the access logic, like for example, if the resource is to be shared in a mutual exclusive fashion, then operating system might provide you the service called mutual exclusion, called as a mutex. Or operating system might provide you the service called as a semaphore. Or operating system might give you the service called as an, for example, message queue, mailbox, pipes, events. Those can be even tuned in order to allocate the resources in more judicial fashion so that there will not be corruption among the task which tries to make use of the same resource at the same time, because that will not be possible. Or when the two tasks tries to share the same resource, then there happens to be a conflict, and that is to be resolved even with the help of this operating system primitives, as I narrated at the moment, like semaphores are there, mutexes are there, which is basically, or the primary purpose of this services of operating system is to manage the efficient use of resource allocation. Okay, so I can see this operating system from this perspective. The definition can be this. From the other, or if we want to see the other perspective, then operating system can be referred to as a control program. What for it is controlling? It is controlling the execution of program in order to prevent the errors and improper use of the computer. This is the most generalized definition that you can see, that it should be making use of a computer system, computer hardware in the most efficient way, so that errors will be prevented and the proper use of underlying hardware would be there. And that is what we started our journey of operating system in understanding as an interface between application program and the underlying hardware. Right. So this can be one of the definition. And having given these simple two definitions, like as there is no universally accepted definition for embedded systems, it depends on the application specificness. Likewise, there is no universally accepted definition for the operating systems also. That's what I said, that it is completely going to be the purview of the way in which these operating systems are supposed to be make use in our applications, right? So still some few sample OS definitions have been given, and those sample OS definition, that is like everything a vendor ships when you order an operating system, is a good approximation definition for this, right? So that is what it said, that everything a vendor ships when you order an operating system is referred to be as an operating system, like the different pieces of services that this vendor would ship along with an operating system, that defines an operating system. That means a device or this particular operating system or the system software that is being used in order to have the time management, memory management, task management, resource management, this intertask communication synchronization, maybe for virtualization, all these aspects that would cover into the definition of this. Okay, so that is what it said, that there is no universally accepted definition. But this definition is widely varies according to the choice for its usage, as we are seeing it, right? But the one program that running at all the time of the computer is the kernel. That is expected to be understood. And that is what, when we say it's a kernel, that is also referred to be as a hardware abstraction layer, as we discussed it long time back, right? So this hardware abstraction layer, again, going to refer the same thing as an interface between the hardware and the application program. Then everything else, either or in your computer systems, everything else either is a system program that ships with an operating system or an application program. That means there happens to be only two categories that comes out with it. The things that you are not writing as an application program, everything that you are not writing as an application program can be categorized to be as a system program, and that can be bundled with an operating system. It's as simple as this. That is what so few authors aims to write this definition also, that everything else is either a system program that ships with an operating system or an application program as such. So in this particular little discussion, that you can understand that the definition of operating system as such, you can mold it according to the usage and function that you need for your application, right? Now let's see that operating system services. As I also referred last time also, and I ask you to refer the article or blog on the internet with a name or title as 10 things that you should know about operating system. So these 10 things are nothing but they are the services and the way in which these services are to be known to us, right? So we'll just enlist these particular services at the moment with a little narration for it. So services of operating, typical services, again, I'll saying the typical services, not limited to these 10 services only, but the typical services that operating system would offer, maybe a process and process management, or I can say task and task management, because applications are modularized, the applications are multitasked. We might need, in order to establish the better control over the execution time of an application, we might need any application to be as a fine application, fine granular application. And that is what managing the task or processes among these applications is extremely important for this operating system, and that becomes its service of it. The second part is the threads and concurrency. Now, needless to say you that you understand the difference between process and thread, right? So when the granularity of an application goes to very high, like if, for example, if any application needs to have, for example, 100 fragments or 100 modules to be prepared for an application, then you can see, you can imagine the context switch or the task switching time, process switching time that might be required by virtue of the context switching. That might not be a feasible one if in order to manage this 100 or thousands of this particular task for an application. So that might not give proper justice to it. That is what a lightweight process is referred to as a thread. Okay, lightweight process is referred to as a thread. When I'm saying it's a lightweight, it is referring to a less context for switching that particular task or switching that particular threads. So when I have, see, process or threads is inherently referred to be as a standalone entity that can be executable. That's it. Any standalone program or any standalone piece of code that can be executed is referred to be as a process, is referred to be as a task, right? But the minimum context, that if you could build up the minimum context, then that is referred to be as a thread. And that is referred or that is said to be as an lightweight process is referred as a thread. Okay, and then we have the multi-threading applications, and these, when we have got the threads, these threads can be executed concurrently for different resources of underlying architecture, just as they are lightweight process. The context that is being expected to be switched to and from the memory, that happens to be very less, and that is what they can afford to get it executed in a concurrent fashion. And that is what concurrency, as we say, that in order to achieve the better performance close to an parallel execution, but not as parallel execution, but more than sequential execution, the concurrent is one of the model that is being taken into account. So built up to build up the concurrency, there happens to be a model that's called thread management modules. Okay, and as I remember that we have discussed it even long back, that this particular thread, or whenever the thread management modules are being written, it is to be written with the compliance of the POSIX. POSIX is a standard that we call as a Portable Operating System Thread Interchange Standard. That means that whatever the threads that you are writing, or when you are creating those particular threads for the hyper-threading or multi-threading, in order to make an application to be a concurrent one, so in that particular case, you might expect that the threads that you are created, those should be ported across the different platforms. Not necessary that only they should be used on the platform where they have been created. That is what Portable Operating System Thread Interchange. This is a standard that gives us, and this operating system adheres with that particular standard. Okay, so in order to have this more details into the concurrent operations, the second operation that happens to be as a multi-threading or concurrency, which is a sub part of process management only. Then scheduling, as we know that in the in this multi-programmed application, the priority of the task, based on the priority, based on different factors, this particular scheduling algorithms are expected to be written, and operating system, as a very important aspect of operating system, happens to be a very integral part of operating system, being happens to be a kernel, and kernel might be there with a scheduler into it. That we'll see in detail. Then memory management, as we all know, that the memory management is one of the very important service that is being provided by operating system, right? We are being known with memory management service as a virtual memory managers, right? So we understand for any and every application that is to be executed, it needs the primary memory. In case of inadequate primary memory, we need to have the memory pages to be swapped in, swap out, and it is to be done in such a way, in the size of pages of 4K. It is to be done in such a way that it feels that virtually an infinite amount of primary memory is available for the application which is running on that particular hardware. That is what the basic concept that we call as virtual manager, or that's called a virtual memory management concept. And this memory management is basically operating system. When we see memory management in operating system, this memory management module of operating system very closely work with the underlying architecture, underlying architectural resources that complements this memory management for it. Okay, that is page allocation table is, for example, one of the resources there. I mean, many architectures has got the memory management support provided from the hardware. So the marrying out this hardware support and the application that user need for memory management is basically the task of memory management. So we have got the memory manager in operating system for that. Interprocess communication and synchronization, everything revolves on the multi-programming, multi-processing, multitasking. So when you have got different number of tasks, as I said you earlier, that you cannot expect that there would not be any dependency among the tasks, isn't it? There definitely going to be a dependency. It's a different matter that how much degree of dependency it does exhibit among these different tasks, isn't it? So, but dependency might be there. So whenever there is a dependency, in order to execute those tasks which are dependent on each other, you might need to resolve that dependencies, right? And the resolving of that dependency or providing an information what is being needed by a dependent task, that particular information is expected to be communicated through services called as an inter-process communication. And as I always said, that inter-process communication happens to be a cause which normally builds up the wave of synchronization, right? And then IO management also happens to be one of the important service, as we had discussed it a few minutes back in this particular discussion only. Then virtualizations is also a very important and interesting aspect of operating system that should be able to give us. And let me tell you well in advance that we are going to make use of the embedded Linux on a virtual environment. So we will have the embedded Linux or the Linux Flare to be customized for our underlying application in Windows operating system itself. So whatever the virtual memory or whatever the virtual machines, those are being there as a part of like operating system. So those virtual machines we are going to make use in order to have the multiple OS to be seated on the same computers. So that is also one of the virtualization tasks that we would do. Distributed file systems, so managing file management happens to be a very interesting aspect, and distributed file system happens to be nowadays, by virtue of getting everything connected with each other, the file management also has got an approach of getting it controlled from a central place as against of getting it controlled at their individual locations. So rather than localized control, I might have this distributed control that might be expected to be there within file system. So this is also an interesting service that you would look out for this for this particular operating system. Distributed share memory, that is needless to say that the memories are getting shared for execution. So again, the mutual exclusive access or the efficiency in sharing the memory among the different tasks also happens to be one of the service of operating system. And we have different kind of memories like uniform memory access, non-uniform memory access, called as a UMA and NUMA memory types respectively. So in this particular things, we can understand that there are different memories are getting shared, and this sharing also expected to be managed in a distributed approach. So this is also one of important service of operating system. And finally, the very interesting and we are all using all this service called as a cloud computing, isn't it? So that also should be incorporated into this operating system services. Okay, I repeat, though we have discussed these particular services, these are not the only services which are being provided by operating system. Apart from this, there are n number of services which are being there. Here you can see that the security, protection, the battery management, nothing is being mentioned. It is being mentioned only like whatever from the application perspective, from the embedded application perspective, whatever is being required, that is being tried to discuss here as an services of this operating system.